Hello, good afternoon students. How are you? Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry. How are you all? Can you all able to hear me and see me? Please confirm in the chat box. Right. So, nice. Today we are going to discuss a very important topic, that is elimination reactions from the organic chemistry. So far we have seen so many sessions on the topic wise or chapter wise, like hydrocarbons and alkanes, alkenes, alkynes, alkyl halides, alcohols. And today I just come up with a kind of classified version, like if you want to prepare an alkene, you need to undergo then elimination type of reactions. So what are the elimination kind of reactions? And in the next session I am coming up with addition type of reactions. In that addition reactions, electrophilic addition reactions and nucleophilic addition reactions, and electrophilic substitution reactions and nucleophilic substitution reactions and like that. Hi रोहन सियानी, मैं ठीक हूँ, आप कैसे हैं? बढ़िया? हाँ मैं बढ़िया हूँ, आप कैसे हैं? So get ready for the sessions here. Before going for the elimination reactions in details, I'm going to explain you the mechanism of elimination reactions E1 and E2, and also how to get a simple tricks to get the question answers from the elimination reactions. Everything we are going to discuss in today's class. I can assure you that from this particular topic you are going to get at least one question from the NEET examination. Good afternoon, the gamer, right? So you want to be pro, or you are already pro, you teach me, I'll become a pro in gaming and all. Okay, so Rohan, right? So in this scenario, I just want to say the important details about this elimination reaction. Before going for this elimination reaction, I just want to take the past results that Infinity Learn that is achieved. So just simple 2 minutes, I'll finish it up and I'll go into the details of the elimination reaction. Stay tuned. Okay, so we have Ashrita and Akilvama and Himadyuti and Sachina, and what you learn about this. So there are 4 students that I am exemplifying this for. They dropped in 2023 examination and prepared for 2024, and they have the score almost doubled. I just want to give you this score comparison that happened in 2023 to 2024 that makes you to just motivate. And they have prepared along with the Infinity Learn various courses. Rohan, and you just see Ashrita 310 marks tha 2023 mein, they got 2024 में 661 marks, 351 marks इनका बढ़ गया, बढ़िया बात है. And you can see Akhil Verma 313 marks in 2023 and 658 marks इनका marks बढ़ गया. Congratulations. Yes, of course. How to identify between elimination and substitution reactions? Stay tuned. अरे आपका असली नाम क्या बोलना? I'm not comfortable that your name is gamer. So if you give your name in the chat box so that I can just call you with your name. Okay, here the students on my live sessions regularly as attending since long back, and they improvised a lot. You can see Himadyuti, she got 310 marks in 2023 and 652 marks in 2024. You can see the score 342 marks iska बढ़ गया. And Sachinarayan also 330 से 650 तक पहुंच गया. Okay, and it is high home and 320 marks इनका बढ़ गया. So 300 से 650 का आसपास में. So which takes you the score NEET 2023 and 2024, the score is more than a double. How it is possible? First, regularity in preparation, commitment in preparation, and the support given by Infinity Learn, and makes them to achieve like this. Not only these 4 students, my dear children, there are hundreds of students got from this, like this. And in 2025 NEET examination, I can assure you that you will be the next to reach on this slide. Ready with that? Are you ready? As you are preparing for NEET examination, you can just, I want to say, crack your NEET examination and grab your medical seat and book your medical seat. For that, you regularly attend these sessions and share with your friends these sessions, and subscribe to Infinity Learn YouTube channel. Yes. Okay, and we are on the Infinity Learn app is there. It is available in the Google Play Store and it is there in the Apple Store. In that Infinity Learn apps, you can just go for any kind of categories based teaching and training. Here live classes are available, mock test, create your own test, and 24/7 doubt resolution. And also Infinity Learn, it is also there on the social media like Telegram channels, Instagram, Facebook and all. And get ready and join. The links are there in the description box. And Rohan, you just see in the Telegram channel, in the link it is there in the description box. You all can join. What is the advantage of this? Daily quizzes, schedules, the जो सेशन आप कंडक्ट कर रहे हैं ना, हर सेशन का स्केड्यूल टेलीग्राम चैनल में आपको अपडेट मिलेगा बेटा. Oh, bad. You can ask them, okay, and you can click it and you can have session notes. हर सेशन का आपका नोट्स मिलेगी. And assignments, daily assignments will be provided in the Telegram channel and many more. And you can just download this Telegram channel. And Infinity Learn, India's first artificial intelligence driven program, is launched. The product is AI Infinity Learn. So your preparation is guided by AI tool. It's amazing, है ना? Now you just see, if you have a doubt resolution by 24/7, it is powered by AI. कहीं भी कभी भी कोई भी डाउट आने तो आप दे सकते हैं ना, ये टॉपिक का हिसाब से आपको पूरा के पूरा का आंसर मिलेगा. And you can just scan the QR code and you can get it. And also goal setting, set your academic and skill enhancement goals by artificial intelligence, and self study packages, learn, practice and revise, सब ये guidelines में चलेगा. And conceptual videos are there, mock test and practice tests are there, and flashcards for the revision is there, and test and paper analysis, and where you are preparing good and we are lacking, everything will be assessed based on that. And also you have the awesome lectures by the awesome faculty from Infinity Learn is available here. Okay, Rohan. Now one more important thing, India's largest scholarship test, that is Score Online, is available, and that is for between the grade 3 to grade 12. You can write, you can ask your siblings also can write. And first बढ़िया बात है कि उसमें India's largest scholarship test का बोल रहे हैं. कैसे? It is scholarship worth of 1 crore rupees सिर्फ आपके लिए, and it is very important, and you just write it. And one more important thing is here, the examination you want to write, you need not have to be part of Infinity Learn. You can belong to Infinity Learn, and you may not be belong to Infinity Learn. You may be studying in some other institute or college. Still you can enroll and you can write the score examination, and you can check the performance. Based on the performance, everything will be available here. Okay, elimination. Krishna, retract your message. Yeah, Giripura scholarship up to 51 crores, sir. Yes, and it is scholarship of 1 crore, and study setup and laptops are available, and educational allowances are available, and up to 100% scholarships are also available. As now description box link is there, you just click it and you can join the link. And the last slide, after this last slide I am going to start elimination. You please You please be patient, one more minute. Okay, now NEET 2025 All India Test Series, a package is available, and it is as a Diwali gift. It was around 6,000 to 5,999, and it comes to be 2,099. And also Singapore tour bhai, kaise? Singapore tour kaise? This is not a Singapore tour. It is for the NEET preparing students. Okay, and for that discount, 50% discount, limited time offer, 50% discount is available once you just enter the code YouTube 50 off. तभी आपको 50% discount मिलेगा. Okay, and also you can see 27 AITS All India Test Series and 20 full syllabus mock test, and also 25 topic wise PYQs and 3 physics, chemistry, biology books and performance reports and everything, and your performance is tracked along with the Sri Chaitanya people over here. And when late you just talk about this special discount, you enter YouTube 50 of the coupon code, and my promo presentation formalities is completed. Let us start with elimination reactions. So what are elimination reactions? So elimination reactions are just seen in the preparation of alkenes. है ना? Yes, you stay here, and in the elimination reactions you can see a carbon to carbon a bond, and there is a group that is leaving over here, and the group that is leaving, the carbon where the leaving group is present is called alpha carbon, and adjacent to it इसका बगल वाला जो कार्बन है ना, इसको बीटा कार्बन पढ़ा देते हैं. And once this beta carbon has a hydrogen over here, so the leaving group is going to be lost from the alpha carbon, and the hydrogen is lost from the beta carbon, so that you can see the formation of a double bond over here. And this reaction is called as elimination reaction. In this elimination you are going to get hydrogen is left, and L stands for leaving group. Now you can see A 1, 2, 3, 4, 5, 6, okay, and 7 sigma bonds are transformed into a pi bond, so that unsaturation is introduced, and this reaction is also called as a beta elimination reaction. Why this is called as a beta elimination reaction? जहाँ पर लीविंग ग्रुप्स का हिसाब से ये कार्बन अल्फा कार्बन होगा and ये कार्बन बीटा कार्बन होगा. So the beta hydrogen is being eliminated along with the leaving group by different kinetics. So this is what you call it as a beta elimination. KOH के presence में करेगा सर? Depend upon the leaving group, you may have to use acid or you may have to use a base. And don't worry, I am going to explain total mechanism for that and coming to the tricks in that also. So I am from Hyderabad Infinity Lane Corporate Office, and I am chemistry faculty, Suresh faculty here, and we are going to discuss about bimolecular, hi porous, hello, bimolecular elimination reaction and unimolecular elimination reaction, E1 and E2, and even CB is also there, but NEET examination के लिए सिर्फ E1 and E2 काफ़ी है. ओके हाँ, आपके लिए हिंदी में बोलना है, बिल्कुल हो जाएगा. Now let us talk about dehydration of alcohol. Dehydration का मतलब क्या? So removal of water molecule. Alcohol से एक water molecule हटाना पड़ता है तभी आपको alkene आ रहा है. You can see this is an alcohol or CH2 or CH2OH. So this is the OH group. This OH group is a poor leaving group and this is called alpha carbon. इसके वजह से ये reference का beta carbon बोलना. So that alpha carbon से a leaving group and इसका बगल वाले जो carbon atom से hydrogen दोनों हटाना पड़ता है as a water molecule, so that जहाँ पर leaving group and hydrogen निकल रहे हैं ना, so इसका बीच में एक double bond रहना है, porous So this session is purely English. If you want me to teach in English, I can teach. You want me to teach in Hindi, I can teach. You want me to mix Hindi and English, I can. Right now, other languages over here. Okay, talking about this dehydration of alcohols. This can go with the E1 mechanism, or you can go with E2 mechanism. Generally, primary alcohols undergo E2 mechanism and tertiary alcohols undergo E1 mechanism. So what is this E1 and E2? Depending upon the molecularity, chemical kinetics, order of a reaction, it is said to be a E1 or E2. You can see here, this is a removal of water molecule, is called as a dehydration. In this removal of water molecule, you have to use acid and heat it. When you use acid and heat it, what are the various reasons that you can use for this acid catalyzed dehydration? Ease of dehydration, first of all, very important point. Her point important here. Ease of dehydration, tertiary alcohols are easily dehydrated as compared to secondary alcohols are easily dehydrated as compared to the primary alcohols, because alkene forms are going to be more stable. Alkenes formed are going to be more stable. So various dehydrating agents that can be used for dehydration of alcohols. क्या क्या dehydrating agents आप इस्तेमाल कर सकते हैं? So आप इस्तेमाल कर सकते हैं concentrated H2SO4, and you have to use this high temperature. Mind it, in the NEET examination, the conditions are very important and the temperature values are very important. When you study something, very simple questions will be asked, but your database doesn't match that simple questions. You can't give the appropriate answer. And you can also say H3PO3 can also be used, phosphoric acid at 470 degrees centigrade. And also you can see Al2O3 anhydrous can be used. It acts as a Lewis acid, of course. And heating with P2O5 or P4O10 can be used. Yes. जब जब रिएक्शन मेटल के साथ होगी तो ग्रिग्नार्ड हो जाएगी, नहीं हो जाएगी, क्योंकि आप जो बोल रहे हैं उसमें आधा स्टेटमेंट सही है, क्योंकि मेटल हैलाइड्स, जब मेटल हैलाइड्स मैग्नीशियम से रिएक्ट करने तो RMgX ग्रिग्नार्ड बनेगी. ओके, कंडीशंस अप्लाई. ओके, ये ड्राई ईथर में करना पड़ता है कृष्णा. ओके, मैं आगे बढ़ दूं. हीटिंग विथ POCl3 भी कर सकते हैं. वी नो दैट acid catalyzed dehydration of alcohol, we know H2SO4, but it is there and Al2O3 in the NCERT textbook. आज हमारा क्लास में आपका करेंगे जो भी एग्जाम्पल है NCERT का कनेक्टेड होना चाहिए, नीट का सिलेबस में होना चाहिए, है ना बेटा. एंड प्लीज मेंटेन द चार्ट डिग्निटी एवरीबॉडी एंड टेक एनी काइंड ऑफ डाउट्स. ओके, एंड प्लीज मेंटेन द चार्ट डिग्निटी. ठीक है बेटा. एंड हीट विथ POCl3, हीटिंग विथ KHSO4. कितना कंडीशंस है? 1 2 3 4 5 6. एनीथिंग कैन बी गिवन, राइट? सो यू आर एक्सपेक्टिंग समथिंग इन द क्लास. आई एम गिविंग मोर देन दैट. यू प्लीज फॉलो अस एंड यू लर्न फ्रॉम मी. आपको कुछ भला करने के मैं कोशिश कर रहा हूं. अच्छा तरफ आप बुक एंड पेन पकड़ के हम जो दे रहे हैं ना, आप लिख के एक चीट शीट बनाओ. नीट एग्जामिनेशन प्रिपेयर करने के लिए चीट शीट मेक्स ए लॉट, है ना. NCERT के क्वेश्चंस लंबा दी है. ओके, यू नहीं, उसमें थोड़ा सा छोटा छोटा फ्रैगमेंट करके आप सॉल्व करो, अच्छा होगा. Whenever you do, सारे के सारा ऑर्गेनिक केमिस्ट्री NCERT है ना, सारा के सारा क्वेश्चंस जो है NCERT में वो काफ़ी है ऑर्गेनिक केमिस्ट्री नीट प्रिपेयर करने के लिए. ओके, इनऑर्गेनिक फिजिकल थोड़ा अलग बात है बेटा. वंस यू आर डन विथ ऑर्गेनिक केमिस्ट्री यू आर डन. ठीक है. एंड मेनी मोर थिंग्स टू कम. प्लीज मेक ए नोट ऑफ इट, मेक ए नोट ऑफ इट. एंड आगे बढ़ते हैं. Next, stability of alkenes. Alkene stability is done based on the hyperconjugation. So this is based on hyperconjugation. So hyperconjugation is also called as no bond resonance. Sir, you are asking me to, you are expecting me to talk about elimination reaction. Then what is the stability of alkene? Why I have to make this slide first of all. So when elimination is completed, the product is supposed to be alkene. So the eliminated product is decided based on the stability of alkene. So rate of reaction of elimination reaction is directly proportional to the stability of alkene. अगर एलिमिनेशन रिएक्शन दो प्रोडक्ट देने का संभावना है, कौन सा प्रोडक्ट मेजर होगी? सो जिस अल्केन स्टेबल है उस अल्केन मेजर होगी. दैट वी आर गोइंग टू डिस्कस. मोर सब्स्टिट्यूटेड अल्केन इज ऑलवेज मोर हाइपर कॉन्जुगेशन एंड मोर स्टेबल. You can see this is let us say all R is equal to methyl group, so that it is going to be 2,3 trimethyl butadiene, and it is going to be 2-methyl butadiene, and that is isobutylene, and the trans-2-butene, cis-2-butene, and it is going to be propene. So as more substitution, more alpha hydrogens, more hyperconjugation, more stable, right? So like that, simple tricks are there. You use these simple tricks and you can do the best. And mechanism of dehydration of primary alcohols follows E2 mechanism. Yeah. And here, this is the one alpha carbon and OH group, and this is the carbon near to it, the beta carbon, and is a hydrogen. And as this strong acid is going to be protonated like this. Once it is getting protonated, it is from the H2SO4, okay, and this OH group is getting protonated. This protonated one is going to be better leaving group. OH is a poor leaving group, ये निकालना क्या मुश्किल है, but once it is protonated, it is going to be best better leaving group. So ये निकालने की कोशिश करता हूँ. कैसे? This protonated alcohol is going to give that conjugate base A minus. That A minus is going to abstract this hydrogen, and there is a transition state, and water molecule is eliminated. As a result of that, A alkene is formed. So this alkene is formed in a single step, that is the E2 mechanism. In this is the alcohol concentration and this is the strong acid. Yes, if you talk about this is the first step. The first step is dehydration of primary alcohol in the protonation. In this first step, second step is attack of conjugate base, that is A minus at a proton, that is a protonated alcohol, and the elimination protonated hydroxyl group is a good leaving group, and it is simultaneously to form a double bond. It is a single step reaction. It is very important. It is very important. Rate of reaction is equal to A minus, that is a conjugate base, and protonated alcohol, and it is a bimolecular, and it is going. What is that? Please maintain the chart. Please maintain the chart dignity, dear students, or otherwise I have to retract you. I have to retract you guys. Simultaneously का मतलब क्या? You just see, yeah, you want to take like this. Simplified version I just want to give you. Okay, now once an acid is added, simple, this lone pair of electron present on the oxygen is going to be added here, and it is going to be now this protonated alcohol is going to be eliminated like this by using a conjugate base. As this conjugate base is taking simultaneously ये extract करने का वक्त में ये bond यहाँ बदल रहे हैं, ये निकल रहे हैं, ये एक ही वक्त में जा रहे हैं. that is the meaning of simultaneous. So इसी के वजह से क्या मिलेगा आपको? you are going to get ये निकल गया. So carbon to carbon double bond, ये carbon to carbon double bond. You understand? Clear? Okay. Please maintain chart dignity, or otherwise I have to remove you from the chart. Mind it. Okay. Anyways, this is arrange the following alcohols in the decreasing order of their ease of dehydration with H2SO4. जैसे क्वेश्चंस नीट एग्जामिनेशन में आ रहे हैं, सो ऐसे क्वेश्चंस देखने के लिए कैसे आंसर दे सकते हैं, उसमें ट्रिक है ease of dehydration. That is tertiary alcohols is more than secondary alcohols is more than primary alcohols. So और एक चीज भी है in this is directly proportional to stability of alkene. Stability of alkene. जिसमें ज्यादा स्टेबल अल्कोहल आएगा उसमें ज्यादा स्टेबल अल्कीन आएगा, उस अल्कोहल इजीली डिहाइड्रेट होगा. Okay, now if that is the case, you can see the order of dehydration C is greater. Why? Because C is greater, it is a tertiary alcohol, more substituted alkene is going to be given, and he is also tertiary alcohol, उस तरफ substitution बहुत कम है, and it is a secondary alcohol, and it is secondary alcohol, and it is going to be a primary alcohol, right? And the ease of dehydration is going to be C is greater than, B is greater than, D is greater than, A is greater than E, right? And one more, rearrangement ring expansion भी होगा. If it is a tertiary alcohol is going to get the dehydration by even mechanism. In the even mechanism you are going to see the rearrangement. Why? Because the carbocation is going to be formed. So in this carbocation formation you can see if it is a tertiary alcohol, what is the mode of, what is the mode of elimination here? Now look at this. This is a cyclopentane methanol. When it is heated with H+, you are going to get a carbocation. This carbocation is 5-membered ring carbocation. This 5-membered ring carbocation is going to form a 6-membered ring carbocation by ring expansion. That is what you call it as Wagner rearrangement. In this Wagner rearrangement you are going to see the formation of cyclohexane, and you feel it is little complicated. I just want to say this one is a cyclopentane and it has a CH2OH. This has a lone pair of electron. When you add H+ to it, it is going to be protonated. It is going to be protonated so that OH2+ is formed. And this OH2+, yeah, I told you please be decent in the chart box, and next time please I am going to retract you. Try to understand, try to involve in the class. हम इन्फिनिटी लॉ के तरफ से हम बच्चों लोग का कुछ भला करने का कोशिश कर रहा हूँ. आप भी अच्छा बच्चा है, सो अच्छा तरफ सुन के आप समझने का कोशिश करो, हमारा तरफ काम करो एंड अच्छा रिजल्ट लेने का कोशिश करो. ओके, चार्ट बॉक्स में ऐसा मत करना. ठीक है बेटा, यू आर गुड स्टूडेंट, बी गुड, राइट. Now OH2 plus is going to be a better leaving group, so H2O is eliminated and it is going to be a carbocation. Now this carbocation you can see what kind of carbocation, chart box में फटाफट डालो, what type of carbocation it is, what type of carbocation it is. Right? What type of carbocation is a secondary primary carbocation. Primary carbocation is less stable and secondary carbocation is more stable. So what happens? So secondary carbocation का ये करने का कोशिश करता हूँ. Okay, and it is going to be a 6-membered ring. This 6-membered ring is formed as this 6th-membered ring is going to बीटा कार्बन से एक H प्लस निकाल के you are going to get the product like this. ठीक है, like this. There is a rearrangement when it is undergoing dehydration reaction. Understand? So based on that we can go for some questions, and also I just want to introduce you Saytzeff rule or Saytzeff rule. You can see from alkyl halides also you can do it. Alkyl halides on heating with strong base such as sodium ethoxide. Sodium ethoxide means C2H5ONa, or concentrated alcoholic potassium hydroxide, KOH alcoholic. So it is a base, conjugate acid base reactions takes place. They undergo dehydrohalogenation. What is the meaning of dehydrohalogenation? Dehydro means remove hydro, halo hydrogen as well as halogen. So HX is eliminated. So dehydrohalogenation takes place. So this is your halogen and this is your hydrogen. ये अल्फा कार्बन है, ये बीटा कार्बन है. अल्फा कार्बन से ये हैलोजन एलिमिनेट किया जाएगा and beta carbon से hydrogen eliminate किया जाएगा, so that it is going to form an alkene, and this is a primary alkyl halide. तो ये E2 reaction का है, ये tertiary alkyl halide होना तो ये E1 mechanism होगा, and in that case this X could be chlorine, bromine or iodine. So the reactivity of the alkyl halides, you can see alkyl iodide is more reactive, then alkyl bromide is more reactive, then alkyl chloride is more reactive, then alkyl fluoride. Of course alkyl fluoride कम react कर सकते. And also you can see tertiary alkyl halides more prone for elimination than secondary alkyl halides are more prone for elimination than primary alkyl halide. And these are the important noteworthy points that I am giving our class में. So live में दे रहा हूँ. So अगर आप live sessions में नहीं available है, recorded session भी देख सकते हैं. Recorded session में अगर doubt आने तो आप comment box में दे सकते हैं. हर दिन में comment box दे के आपका आंसर वापस देना चाहता हूँ. तैयार है बेटा? So कृष्णा, are you there? Fine. करना है क्या? Okay. So आगे बढ़ेंगे. So here you can say iodoethane, ethyl iodide, KOH alcohol. If we heat it, you are going to get ethene. And also this is a dehydrohalogenation reaction. And you can say bromine and 1 bromopropane, you are going to get a propane. 1 bromopropane, you are going to get a propane. And also the process in the removal of molecule of halogen halide HCl or HBr or HI from an haloalkane, I mean to say alkyl halide, you just generalize this as a RX. X stands for halogen, and to form an alkene is called as dehydrohalogenation. You know, dehydrohalogenation is an example of a beta elimination reaction, क्योंकि इसमें reaction of hydrogen निकल रहे हैं बीटा कार्बन से, एंड हैलोजन निकल रहे अल्फा कार्बन से. सो बोथ अल्फा कार्बन से हैलोजन एंड बीटा कार्बन से हाइड्रोजन दोनों निकल रहे हैं. सो दैट ए पाई बॉन्ड इज इंट्रोड्यूस्ड. So it is an elimination reaction. So it is also called as a beta elimination reaction. The ease of dehydrohalogenation of alkyl halide, the same alkyl groups are different alkyl groups. Okay, it is alkyl iodides are more reactive and alkyl bromide is more reactive than alkyl chloride is more reactive, while isomeric alkyl halide having the same halogen but different structure is there. Tertiary alkyl halides is more reactive than secondary alkyl halide is more reactive than primary alkyl halide. So the tertiary alkyl iodide is most easily reactive. समझ में आ रहा है क्या? और कुछ डाउट है ना तब पूछ सकते हैं. It's very important. This is a noteworthy point. You all use this and note it. Take a pen and paper. We'll do a couple of questions based on that. And आगे बढ़े. Saytzeff rule is also called as Saytzeff rule. Saytzeff rule, depending upon the structure, alkyl halides may give one or more isomeric product. So what Saytzeff rule says? For example, dehydrohalogenation of 1-chlorobutane. So in this 1-chlorobutane, if it undergo elimination, this 1-butene is the only one product. You want to go with this 2-chlorobutane. When you go with the 2-chlorobutane, you are going to see CH3, CH2 and CH and CH3 and chlorine. When you undergo dehydrohalogenation with KOH and alcoholic and you heat it, so elimination is an endothermic process. And you can have elimination between these two. So you can have CH3 and CH2 and CH double bond CH2. You can have elimination between these two. CH3 and CH double bond CH and CH3. So you got but 1 in. You got but 2 in. You got but 2 in. So but 1 in and but 2 in. So this but 2 in is the major product in this reaction. Why this is major product? So it says, Saytzeff rule says, during beta elimination, the product formed is going to be the most stable alkene, most substituted alkene. During elimination reaction, if more than one beta hydrogens are available, you have to remove the hydrogen from a beta carbon where the carbon bear the less number of hydrogens. That is what you call it as Saytzeff rule. And elimination process, Saytzeff rule, you have to use it as a student continuously preparing for examinations. Whenever you just go with the Saytzeff rule and Markovnikov rule, you have a kind of confusion. So always use Saytzeff rule or Saytzeff rule, both are same, pronunciation is different. So Saytzeff rule can be used for elimination reaction and Markovnikov rule can be used for addition reaction, provided that condition if there is no rearrangement in any kind of reactions. Okay? So like that, from me you can expect very good number of tricks like that, and you can use these tricks and you can get an awesome score in organic chemistry with a specialized lectures from the Infinity Lane. You all follow with us and you regularly attend the sessions with us. You are going to get the best. Okay, and आगे बढ़ते हैं. Yes, when bulky base is used, the potassium tertiary butoxide, that on the tertiary butyl alcohol in the presence of salt. And for dehydrohalogenation of alkane, less substituted alkene is the product. It is opposite to Saytzeff rule and it is called Hofmann rule. Who is that, Samrat? Retract your message. I am going to retract that. So I mean to say here, whenever this potassium tertiary butoxide is a base is used, potassium tertiary butoxide is used, you can say this is your leaving group, so this is called alpha carbon, and this is your going to be beta carbon, and this beta carbon has a beta hydrogen, and it is also beta carbon has a beta hydrogen, and this tertiary butoxide can get this hydrogen over here or this hydrogen over here. So if that is the case, you are going to get 2-methyl-butene is the product and 2-methyl-butanone is the product. In this scenario, 2-methyl-butanone less substituted alkene is the product. If this less substituted alkene in the presence of bulky base, this is a bulky base, this is called Hofmann product. And this Hofmann product, when Hofmann product can be formed? When this Hofmann product can be formed? This Hofmann product can be formed whenever, condition number 1, the base is bulky, whenever the group is a leaving group, and also whenever thermal decomposition reactions are there. So in these 3 conditions, product is going to be Hofmann product. So if not the condition, generally the product is going to be the Saytzeff product. Hope you understand. It's a valuable point. What are the conditions to form Hofmann product? 3 conditions आपको दिया गया. Whenever the base is bulky, whenever the leaving group is poor leaving group, and also whenever these thermal decomposition reactions, thermal elimination reactions like a cope elimination kind of things, you are going to get the poor Hofmann product. And also stereochemical requirement for E2 dehydrogenation. So in the elimination dehydrohalogenation, you are going to get 2 eliminating group must be in the trans position and must yield an anti-elimination product. So anti-periplanar structure. I wanted to say here the carbon and this is a tetrahedral and this is your hydrogen and this is your bromine, and when you use this a potassium hydroxide and you heat it, so what happened, this potassium hydroxide gives rise to the base, so that base is going to interact like this. As a result of this is going to form a transition state. As this transition state, you can say right, and this hydrogen and this OH is going to make a bond like this, and there is a transition state. This is what you call it is a transition state. This transition state has to be stable whenever this hydrogen and bromine are in the opposite sides. They should be trans indeed. So as this bond is formed here completely and this bond is going to be relieved. As a result of this, you are going to get a product like this. It is eliminated as water molecule and you got the product like this. So sp3 carbon become sp2 carbon during this, and I mean to say when this cis 1 bromo 2 methyl cyclohexane. Of course, if you just take this bromine and this carbon atom and this carbon atom and this hydrogen in one plane and this hydrogen in another plane. So this hydrogen should be formed. This hydrogen should be released as a bond and it is going to form a more substituted alkene. So this and this supposed to be in opposite way. So this is anti-periplanar structure. Okay, and it can be done here also, and it can be done. So if it is done in the circled one, you are going to get a major product over there, and this is another product. And more substituted alkene, it is stabilized more by hyperconjugation, it is the major product, and it is stabilized by less hyperconjugation, so it is less stable. So, and you can see, if you anti-elimination can occur only in one way, the trans isomer. If this is the case, if the bromine is there and the bromine has no hydrogen over here to be in anti position, so that elimination do not takes place, here elimination takes place. If that is the case, you are going to get the product away from that. So it is going to be the major. And also you can see, predict the correct order of reactivity of the following compounds in dehydrohalogenation. Take a minute and complete this. Take a minute and complete this. Make it fast. Take a minute and complete this. And I want the answer in the chat box. So it is a primary alkyl halide. It is also a primary alkyl halide, and it is a primary alkyl halide, and it is also a primary alkyl halide, more bulky, and it is a primary alkyl bromide, and it is a secondary alkyl bromide, and it is going to be tertiary alkyl bromide. Among primary and secondary and tertiary is going to be more reactive, and among the primary, this is secondary. Okay, among the primary and secondary, this is your again primary, it is also a primary. Among the primaries, bromide is more reactive than chloride, है ना? So that we can say the correct order is going to be, so 5 is more reactive because this is a tertiary, and the third is more reactive because it is a bromide, and it is going to have the bulky, and here it is going to be secondary, and the order is going to be 5, greater than 3, greater than 2, greater than 4, greater than 1. And also, could you say the concentrated H2SO4 in the major product? What is the major product of this reaction? A, B, C, D. Make it fast. And you want me to give the mechanism for that? This I would like to write. Look at this carbon, and it has a 3 methyl groups. It is a methyl group. It is a methyl group. It is a methyl group, and it is going to get CH and CH3 and OH. In the presence of H2SO4, let me write carefully the mechanism. First of all, the OH group is a poor leaving group, and it is going to be a better leaving group when it is protonated. Once it is protonated, it is going to give CH3, CH3 and CH and CH3 and OH2 plus. And protonated alcohol is better leaving group, so it is removed as a water molecule, and it is going to be CH3, CH3, CH3 and CH and CH3 plus. It is a secondary carbocation, my dear children. So the secondary carbocation is less stable. So it wanted to be more stable carbocation, dear children, so that this methyl group is migrating here. Okay, in this scenario, I just want to say CH3, and it become a tertiary carbocation. And this hydrogen is eliminated as a proton. This hydrogen is eliminated as a proton. This is eliminated as a proton. It is going to give CH3, CH3, CCH3, and double bond CH3 and CH3. You see how simple when you are so precise in your mechanisms and all. I don't want to say this much mechanism you can get through it, but मुफ्त में नहीं मिलते, आप ज़्यादा मेहनत करना पड़ते. When you go with that kind of approach, you can give the appropriate answer. This is your appropriate answer for this question. Understand, dear children? Clear? And I just want to give you a question over here. What could be the product over here? What could be the product over here in this mechanism? H2SO4, and write the IUPAC name of this product in the comment box. So today we discussed about various types of elimination reaction in the preparation of an alkene. Once you have acclimatized with one kind of mechanism and one kind of methodology, you can do 100 different kind of questions. And I promise you that you can do the questions well from any of the source of book that you have. And hope you enjoyed today's class. Students, you please like the session and share with your friends and comment anything you have a doubt and the answer IUPAC name of the product in this comment box. Okay, thank you very much. Signing off, Suresh, Faculty of Chemistry. Thank you.